Okay, so we're going to look at, I had nothing better to title it, but more parametrics. So we know that parametrics can show us a lot. They can show us direction, we can figure out distance from that, and we can see more than we could with just rectangulars. But they allow us to control how much of a function is graphed, right? So it's kind of like we get to restrict our domain and our range by using that parameter instead of actually having to use a domain and a range and know to only graph that amount. So we're going to do some more calculator stuff. So here's what I want you to do on your calculator. Go ahead and change it to this mode. And I can only put my calculator on the left, which is so dumb, but it's just the way it works. So I have to look on one. So we want to go to the mode. We want to make sure we're in radian mode. And go to parametric. Oh, dang it. We do? Did I not? Oh, it's 149. I couldn't. Shoot, I messed that up too. All I did apparently was change the title. It's 149. Thank you. I can't change it from up here, but it's all good. We'll come up here. We can easily make a 7 into a 9. There we go. Like Bob Ross. We'll just make happy birds and it's all good. All right. So we put it in radian and parametric. And I got that. All right. So then we're going to change our window because you're being told what to do. So on the window, my T minimum, we're going to make that a -2. And it's fine if it's like a generic problem to think about that T as time is good. Just remember it's not always time. And then a horizontal and vertical distance. That's kind of a good generic way to think about what's happening here. Then our T max is going to be 2. And our T step is going to be 0.1. And then our viewing rectangle, which is just your X max and min, is going to be 0, 15. And then scale is going to be the same, and then -5, 5. Okay. Then in y, we go to y equals, whatever you have there, if you didn't clear it out, go ahead and clear them both out. And we're going to graph these equations. 3t squared and 2t. And we're going to graph it. We're just going to kind of look at it. So looks like a parabola, right? But you should notice that it doesn't actually continue, right? And it's not a function because it laid down, right? This would be like the inverse. So what's happening with the T max and the T min, or the T min and max, they determine the length of time you want. And the T step determines how often you want the calculator to plot a point, because that changes how it looks. But right there, that gives us part of a parabola, right? And we can just kind of, over here, this isn't really part of one of the examples anyway, but this is what the graph kind of looks like. So just sketch it like that and good enough for right now. Okay? We're going to look at the other ones where we actually do some stuff. But all right, now, T step determines how often we want the calculator to plot a point. And that we can kind of leave how it is. But we're going to change the T max and min at some points, and we're also going to change the viewing rectangle. And within this, I'm going to show you some other calculator things that can be helpful not only for this, but for any time you use these calculators, which I think some of you know some of them and some of you really don't. So first here it says on number 1, it says write parametric equations to graph on the interval -2 to 2. So remember, this is your T min. And this is your T max. We're not ready to graph yet, but that's what these are going to be. Okay. Now it just says write parametric equations. It doesn't tell you what to do, what your T is, anything like that. So if you just want to change this to a generic parametric equation, Cody, then we can just say that x equals T. Right? If they didn't give me anything, I can just make x equals T. Which means that writing the y version of it, super easy, right? Because you just substitute it in. So basically, you're changing all of your x's to t's. So y equals 3t squared plus 5t minus 1. And there are your parametric equations. Okay. So we're going to sketch our curve before we even look at the calculator. We're just going to sketch our endpoints. So don't graph anything yet. And I didn't put little graphs on here because I figured I wouldn't do them right anyway. So we need to find our endpoints, and we know what our max and min are. So if I make a little chart here, so for t, x, and y, so I'm looking for -2 and 2, right? So x would be -2 and 2. Then when I substitute this one in, y equals 3 times -2 squared plus 5 times 2 minus 1, -2. This is going to be 4 times 3, which is 12, minus 10 minus 1. So what do you get for y? 1. Okay. Now, you're all capable of this, right? You can totally substitute those in. Do we ever make really ridiculous mistakes on this kind of stuff? Yes. Let's look at how we can actually figure this stuff out here. Let's go graph them. So let's just graph it before we even look at the other one. Let's see. X equals t, so I'm going to clear this out. Y equals 3t squared plus 5t minus 1. Okay. So when I do this, now I'm going to graph it, and that's clearly not the window or anything else that I need. That's one of the reasons why we wanted the endpoints before we did anything else. But how could I go figure out what this is going to be without having to do any work? What's one way? Table. Okay. So I can go look at my table. And so when t is 2, what is y? 21. Okay. So let's go back to our graph here then, and we're just going to kind of sketch this out. I'm going to go to -2, 1, right? And then I'm going to go to 2, 21, and I'll just make that like that, and then there's my scale, 21. Then I'll figure out where other points may go. So now do I have an idea of what kind of window I may need? Because I have the endpoints. This isn't going to continue, right? Those are my endpoints. I'm not going any farther. So clearly, I don't like this when I graph it, right? I know that for my window, my Tmax and my Tmin happen to be what I want them to be. Then when I go to my Xmin for my actual graph is really -2, but what would be a good thing to put here? -3 maybe. And then my Xmax, maybe 3. My Ymin, not really sure exactly how far it may go down, so I might just leave it as to what it is right now and just see if maybe I need to change it, but without a whole bunch of guessing and checking. Clearly 5 isn't going to work, so what would be a good top end? 25? Okay, we'll go with 25. And then we'll graph that. All right, so that looks better, right? That kind of gives us a better idea of what I actually want. And when you, if I want a second calc, if I want just to do a value, I can type in my t values there. Do y'all ever do it that way? You know how to just find values instead of using the table. So instead of using the table, what I did was, because sometimes you have to scroll on tables and they don't give you the ones that you want, and it's like an in-between number and you can't find what you need. Well, instead of asking us for x like it would if we were in the function mode, it's asking me for t. So I got there by doing second calc and then choosing value. These are derivatives. We're not really into that stuff yet. And so if I do my t and I type in -2, well, it gives me the x and y values that I needed. So let's try t equals, I don't know, let's do 1. Second calc value, because I'd like to know what's happening right around here. We'll do t equals 1. So when t is 1, x is at 1, 7, right? So we can go to 1, and then 7 would be about 1/3, so maybe right about there. And then we'll just write it in here. So let's look what happens at -1. Second calc value, -1. Well, when it's -1, it's -3. So at -1, -3 isn't going to be super far down because of my scale, so I think maybe right about there. So I think 0 would be helpful in there as well. So I know x is 0. Let's see what's happening with y. So did you notice how that time I didn't hit second calc? So here's where I am. We were here and I typed in -1, right? And it gave me my answer. Oh, maybe not. What the heck did I do? Second calc value -1. Okay, so we were here and I just got that one. Well, instead of doing second calc value every time, since it already asked me that and gave me an answer, I'm just going to type in my new t, which is 0, and I didn't have to go through all those steps again. And so then I get 0, -1. So it's about right there. So it kind of saves you some keystrokes, which can be very valuable when you need a whole bunch of stuff, which I know we could have gotten some of this from the table. And you see what the curve looks like? So your curve looks like that. But again, you have to be capable of substituting it in and getting it. And I think that you totally are capable of that. But then you can also use the calculator for all that. So we made the sketch of the graph. Then it says state the domain, the range, and the viewing rectangle. Okay? So our domain here, what is our domain? -2 to 2. Right? It happens to be the same as this because t equals x. My range is what? -3 to 21. And then my viewing rectangle is whatever you put your window at, which is not necessarily the same. I mean, ours is probably all the same right now, but we went from -3 to 3 and then from -5 to 25. And those answers could vary, obviously. Viewing rectangle, it's the window you use, the x min and max, y min and max that you used on your calculator. Which really, we didn't have to go all the way to 25. We could have left it at 22, right? But you don't have to go in there and like make it exact because it's a little bit different than domain and range, but it shouldn't be that much bigger than your domain and range, basically. We all good? Okay. All right, I'm going to skip. Let's skip to number 3 because number 2 is very much like that. You would just do x equals t. And I want to make sure we have some time for some of the other ones. Bless you. So 3 says, write parametric equations for a circle with its center at the origin and a radius of 2. Okay, so here's a couple of things that we know. We know that we can write a rectangular equation like this. Now I want you to think, if I'm going to have to make that into something where I'm going to have to substitute something in, there's going to be some square roots. It's going to be hard to get the whole thing. Have y'all graphed circles? Have we graphed circles on the calculator in here yet? Maybe not. That's why I don't think we did. All right, so we're going to just, for the heck of it on this one, to see what's going on here. We're going to do this in the rectangular form first. X squared plus y squared equals 4. That's what that would look like in rectangular form. If I want to go graph that, and the only way you used to know how, which is in y equals, so we're going to put our calculators back in function mode for just a minute. We have a y equals kind of situation, right? So I have to solve this for y, which means I'd get y squared equals 4 minus x squared. So y is equal to the square root of 4 minus x squared. Is that what it would look like? Cody? Is that what it would look like? Or what am I missing? Huh? Plus or minus. I would need plus or minus because if I just do one of them, it's only going to give me half of the circle, right? So I can go to y equals, and I can type in square root of 4 minus x squared. And then I'd have to do a second one and do negative square root of 4 minus x squared. Now, clearly my window is like funky, right? Because of whatever else I did because I didn't clear mine. So let me just do zoom standard. Zoom 6 will get you back to the standard default. And it's kind of squished, right? Why is it squished? Because we know what a circle is supposed to look like, right? It's because your window is rectangular, right? Your window is rectangular, and which means your little grids aren't squares like they should be on a piece of graph paper. So remember, zoom 5, the square, it squares it up so things actually look right. But you got to go through all of that because the y equals only graphs functions, and I have to do it that way, right? But we are going to do this to where it'll actually graph the whole circle because we're going to look at it parametrically, or we've also graphed them and looked at them as polar equations as well, right? So let's think about what we know from our circle. When we were talking unit circle, right, and we had these points on here, whatever the point, that's that point right there on the circle. The x value of a unit circle is what? No, just any x value when you have the unit circle is represented by what? Sine, cosine, tangent, what is it? Cosine. So it's cosine on a unit circle. But when it's not a unit circle and I don't know, if I don't have the radius, then your x value, this distance here, even if it's here, your x distance is r cosine theta, and your y distance is r sine theta. Does that make sense to you? That's what's happening. Remember that we're looking at, it's not a time type of thing anymore. Our parameter is not t, our parameter is theta. It can be an angle. So this point right here has two distances tied to it. It has an x distance and a y distance, right? And so in order to get this ordered pair that looks like this, your x and your y is r cosine theta, r sine theta, just like it was before. Does that make sense to you? Just like it was for circles when we did them, just like it was for when we did unit circles and trig, just like we did for polar. Because when you look at this stuff, we know that we had cosine theta is equal to x over r, right? And sine theta is equal to y over r. Do you remember that stuff? Okay? So guess what? Your stuff is pretty much already written for you. What does r represent? The radius. Do we know what the radius is? Yeah, we do. So we know that cosine theta is equal to x over 2, and sine theta is equal to y over 2. And that's where my brain was going when you asked that other question. That's why I stumped me when they weren't the same. Which means I have my parametric equations right here. X equals 2 cosine theta, y equals 2 sine theta. So we have seen that x equals r cosine theta in multiple different situations. And remember, that's the same as your like mg cosine theta, mg sine theta that you use in physics. That is your parametric equations. Now, theta, even though theta is our parameter, we still use the variable t, okay? Because remember, t can equal time, it can equal temperature. Here it's a degree measure. So to really, really get those, it is t, I guess I can write here. X equals 2 cosine t, and t is just theta. Y equals 2 sine of t. These are your parametric equations. Okay. So then we are supposed to draw a sketch of the graph. Well, do you know how to sketch it without even looking at the calculator? Like, it's centered at the origin, radius is 2. Sketching it on the calculator isn't going to make your circle look any better when you draw it, right? We're still limited by what we're actually capable of. Yeah. If it looks like you attempt a circle, we're good. But what I want to do now is I want to graph it on the calculator parametrically. So we are going to go back to parametric mode. Bam. We're going to go to y equals. And we're going to clear those out. So our x is 2 cosine t, which really you're hitting the theta button anyway, and 2 sine t. And then we're going to graph it. Okay? And we might get something kind of weird at first, so we'll think about what happened there. Is that kind of what you got? Okay. So why do you think we got that and we didn't really get a circle? Because our t min and max is not good, right? If I want to draw an entire circle and I start at 0, what does my t max have to be to get a circle? 2 pi. Now, if it was 4 pi, I'd go around twice. I only have to go around once. So here I have to go in here, my T min and max. -2 doesn't really even, I mean, we can have negative angles, but we're talking radians here because we're in radian mode, aren't we? Oh, yeah, we're in radian mode. So we're going to go here. So my T min is going to be 0, and my T max is going to be 2 pi. And you literally type in 2 pi. T step is fine, but could we fix the X max and min a little bit? Yeah, because we know what it's supposed to look like. So maybe we'll go from -3 to 3 and -3 to 3. And we'll graph that. And then that graph's almost still kind of looks like a pumpkin or an egg, right? But the same issue is happening is that it's a rectangular window, even though we tried to make it square by going -3 to 3. So if you just do zoom square, it fixes all that for you. But you want to get your window right before you hit zoom square and let it figure out how to fix it without knocking your stuff off the screen. And then there's your circle parametrically. Okay, we good with that? All right, so let's look at the next one and see if we can figure out how to write this. Now let's think about it rectangularly first so you can wrap your mind around it. I know the center is at 5, 2, so that means I get x minus 5 squared plus y minus 2 squared equals 9, right? When we graph this, that means the center, which is at 5, 2, is right here. And then you got to go 3 this way, 3 this way, 3 this way, and you get something that looks sort of like that. So we know that this distance right here, whatever it is, this x value, if this was at the origin, this would be r cosine theta. You agree with that? But this point got moved. How did it get moved? From the origin, just the x value. It went to the right 5 and up 2, right? So whatever this x value would be if it was at the origin, I have to add what to it? 5. So my r cosine theta, x equals r cosine theta plus 5, because it moved to the right 5. Or the value actually increased by 5. It's not just a movement. And then y equals r sine theta. What would I have to add to that? 2. Notice that it's not a subtraction thing for x like it would be if it was a function, right? We are literally adding 5 to the x value to move it over and literally adding 2 to the x value to move it up. So my actual parametric there then would be x equals the radius, which is 3, cosine t plus 5, and y equals 3 sine t plus 2. And since these numbers are the same, that's how you know that it's a circle. That's why I knew the other one had to be an ellipse because the numbers were different for them. And there you go. And then we can go in there and graph that if you want to. Do you understand how to add that? It's just a simple addition. If you can wrap your mind around how you don't necessarily have to write this first, but I just wanted you to see that that's what's happening. That's what you can plot that without even knowing this part right here anyway. But you've got that, and you're literally adding 5 and adding 2 to the y and x values. We good? All right, so let's look at the next one. It says, use the graphing calculator to find a complete graph of the following parametric equations. And so it gives them to me. It just gives it to me. I'm typing it in, right? So we're going to go to y equals. I'm going to clear out what's there. I'm going to type in t cosine t and t sine t. Now before I hit graph, or I can hit graph and then go, maybe it's right, maybe it's not. I'm not really sure. But what did I not change? I need that, right? What does that represent? This represents my T min and my T max. I may have to fix my window, we don't know yet, but I have to fix my T min and max. So my T min is 0, I'm good. But this was at 2 pi. I wanted it 4 pi. I'm going to graph it. Bless you. Now, we get kind of the same thing. I'm like, oh, maybe that was right, maybe it wasn't. But maybe I don't see enough of it, right? So I can go in there, I can play with the window, but I could also do what? Zoom out. I'm just going to zoom out, and when you hit 3, like, it looks like nothing happens. This is asking you where it wants you to center the zoom. You almost always want it to center the zoom at 0, 0, so you can just hit enter and it'll zoom out for you. But sometimes it zooms out a little too much, but it at least gives you an idea of what's happening here. And that's really not so bad, actually. So then when you go to sketch the graph, you can use what you have here. You know what it's supposed to look like, but you can do the second calc and get the values you need to actually get the pieces in there. Does that make sense to you? Just, you need to know how to manipulate the calculator. That's important. All right. So we'll just, I'm going to sketch this. Here's my disclaimer. This is not enough to be okay. You have to go in there and put some values. But you can kind of get the sketch and then go and put your values in. All right, let's look, because I want to graph 5. Let's go graph 5. We're going to go back to y equals. We're going to put in 5 sine of t and 5t cosine t, because this one's pretty cool. Yeah. And then it gives me my t min and max, so I'm going to go fix that before I ever do anything else. 0 and 20.5. I clearly did something wrong. Oh, no, I didn't. Yours looks like, okay. Okay. So it looks weird, right? Now I realize, now I remember why it looks weird. We're going to zoom standard. It's because the zoom is weird there. There's still something not right. What did I do wrong? That's what yours looks like? I graphed this. Okay. Let's change our window. I'm going to give you what to. This is a complicated one. There's not a complicated one like this on your homework. I just wanted you to see this one, so I'm just going to give you what this is. I think this is the problem, and I don't know why I can't see it enough to. We're going to go. So you're going to go from -8 to 8 on x and -100 to 100 on y. That's definitely the problem. Yeah, there we go. And then when you hit graph, watch yours graph it and watch how. It still doesn't work, and then I don't know why. What the heck? What did I do? Oh, I didn't change my min and max. I thought I did. That was the problem to begin with. I said go in there and do it, and then I didn't do it. So 0 to 20.5. And maybe, oh, it changed it, and then when I hit zoom standard, it put it back. That's what happened. Dang it. Smarter than me. But then watch how it graphs it. And it's a spiral, but it's kind of a different kind of spiral. To where if we added a z value to it and made it 3-dimensional, then sometimes they end up looking like springs. Okay? So you can graph things that are more lifelike with parametrics. And again, don't worry, there's not anything crazy like this on your homework. I didn't give you crazy ones. But they do have a whole lot of applications that unfortunately we don't necessarily get to. And you probably did some of it in physics, but you may not have made the connection to know that it's parametrics. But I took some of this numbering isn't right because I took a couple of them off. But you need to use the graphing calculator, so make sure that you are using the one, either have one that you have or that you have downloaded it from